Okay, Munchkins, this is going to be a first in a four-part screencast on accuracy and precision and sig figs. And this one, I'm going to cover just kind of the difference between accuracy and precision and what we're talking about. My integrated mammals will know this as topic 3A. Okay, so let's get to it so we can make this a short one. Accuracy and precision, they're sort of used interchangeably in everyday language, but to a scientist they tell you sort of subtly different things. For instance, accuracy is how close your data is to whatever the accepted value is. So if we're doing a lab, I will probably know where your results should be, and so that's going to be the accepted value. And your accuracy is going to be a measure of how close you are to that accepted value. You might be calculating later on when we get to the labs that require it what we call a percent error, and that's going to be a measure of your accuracy. Precision, on the other hand, is let's say you take some replicate data through the lab, how close those repeated measurements are to each other. And so what we're trying to measure here is your technique and the quality of your equipment. If you've got good technique, you're doing everything sort of the same way, and you've got reliable equipment, we expect your data to come out all close to each other, and so you would end up with high precision. And we're going to look at some examples to show that you can have each of these individually. For instance, you can have high precision but low accuracy. So I'm going to start off with some examples before I get to this last statement. Use some bullseyes because everybody sort of understands bullseyes. And the X in the center would represent the accepted value. So we'll start off with like the best possible scenario. So those will represent my data points. Clearly we've got high precision because my data points are all close to each other. And they're also close to the accepted value, so I have high accuracy. So that's great, has both of them. Next situation, say you get this. And again, we've got high precision because my data points are all close to each other, but they're not close to the accepted value. So I would have low accuracy. And in the real world, this is not too bad because this means that you've got good technique and good equipment. Your data points are all close to each other. We just need to maybe, recalibrate things to bring it on to the accepted value. Okay, now what you don't want to see is a situation maybe kind of like this. This is no good. We don't have precision. Data points aren't close to each other. And they're sort of randomly distributed here. We've got most of them over on this side of the target. And then we've got this flyer over here. So even if we average this, this isn't going to be on target. So we also have low accuracy. So this is no good. It doesn't have anything, nothing, no redeeming qualities about this data set. Okay, so coming back to this last point to finish up here, and this is the situation that a lot of students miss because they think it's this. You can have high accuracy with low precision, but only if you think of the average of the data points. What a lot of students think when you have high accuracy is they think of this situation. They think, okay, to be accurate and close to the target, that forces me to have high precision also because all the data points would be close together. But we can have accuracy on average, and that would be if you had some situation like this. So we don't have precision. My data points aren't close to each other. But it's different from this situation in that, see that they're all sort of symmetrically distributed around the accepted value. If we average this, the average value of those 5 points would be very close to the accepted value. So this would be high accuracy on average. No individual point could be trusted, but the average of all the points could be trusted. So watch out for this situation. This is the one that gets missed the most. If you've got points and they look like they have low precision, that's kind of easy to spot, but make a quick average of them to see if they fall into this situation. So that's the difference between accuracy and precision. I hope this helps, and that'll be the end of this first part on accuracy, precision, and sig figs.